Welcome to Porpoise Survey Analytics Tutorial, Chapter 2, Results and Crosstabulation. Let's go first to how to secure the results for any given question. We go to the question list and then select a particular question clicking on the radio button. Up in the left-hand corner, the results for that question are displayed. In this case, we're looking at the question regarding high-speed rail in California. Specifically, we want to know what percentage of those surveyed approve of high-speed rail, which in this case is 29.8%. What percent oppose, 56.2%, and what are still undecided, 14%. If we come over to the third column, we can see the sampling error associated with each of those responses. We also see a very important feature of Porpoise, and that is the interpretive index, or what we will call the index. We describe an index in terms of a positive, in this case approve, a negative, in this case oppose, and perhaps an undecided. The formula for calculating an index is the percentage of responses positive minus the percentage of responses negative plus a constant of 100 to get rid of negative values. That means that index values can range from a low of 0, nobody has a positive impression, to a high of 200, everybody has a positive perception. By itself, the index value doesn't tell us a lot, but as we will see in subsequent chapters, it's very useful in comparing across questions, especially questions in a block, or when we want to look at cross-tabulation and subgroups, and we want to compare subgroups from one question to another. I want to draw your attention also to some additional possibilities for this results screen. We can look at the results in terms of the total N, or we can accumulate the results. This is helpful if we have a question with a lot of responses in ascending order. Or we can show an inverse cumulative, which starts at the bottom and adds up. If we come down to the analytics screen, we can see a display graphically of the table that we just saw. The last thing I would draw your attention to is the text window above. We can display the entire wording of a question by simply clicking on the question stem. Were this in a block of questions, we could view the block stem. And these remaining functions are to allow you to take notes while you're using Porpoise and export those notes later on. Now let's look at cross-tabulation. Going back to the question list, we can cross-tabulate that question with any other question in the survey. Most often we will be cross-tabulating that with some kind of an independent variable. So let's choose, in this instance, party registration. We will cross-tabulate high-speed rail by party registration by simply clicking on the label for party registration. If we go over to the analytics screen, we can see the cross-tabulation portrayed both as a table and as a graph. A cross-tabulation involves a dependent variable and an independent variable. The dependent variable, in this case high-speed rail, is the question that we're interested in. The independent variable is the question we use to break that down. Or we can think of it as the dependent variable, the question of interest to us, and the independent variable as the question which helps explain the dependent variable. An even easier way to conceptualize this is we can think of the independent variable as the cause and the dependent variable as the effect. Now let's look at this table. An easy way to interpret a cross-tabulation table is to look across the levels of the independent variable and to mentally insert above each level of the independent variable the word among. We can then interpret the table to say among registered Democrats, 41.8% approve, 39.6% oppose, and 18.7% are undecided. Among Republicans, we can see that fewer than 1 in 5 approve, almost 3 out of 4 oppose, and about 1 out of 10 are undecided. Among declined to state and other party voters, a little less than a third approve, 57% oppose, and 12.5% are undecided. Also on this table are the index values now calculated for Democrats, that's 103, Republicans, 45, and declined to states, others. What does this mean? This means that 3% more approved than disapproved of high-speed rail among Democrats. Among Republicans, the margin was in the opposite direction. The last line of the cross-tabulation table shows the marginal percentages. What this means at a glance is that our sample was comprised of 45% Democrats, a little less, 43.8% Republicans, and 11.2% declined to state and others. Now let's look at that graph below. Here we can see the same thing as the table, but now it's visually portrayed. If we choose to look at percentages rather than looking at the interpretive index, we can simply click on the graph positive and negative, and now the graph is redrawn and a legend is provided that shows the blue bars are the percentage positive for each level of the independent variable, and the red bars are the negative. If we go up to the top right-hand corner, we can see the statistics window, which gives us a number of statistics that are automatically calculated every time we do a cross-tabulation. Let's go through those and then let me explain what they mean. The first statistic calculated for this type of a cross-tabulation is called a chi-square. This is what we call a test of statistical significance. And what statistical significance means is that the differences that we observed below are simply too big to be due to sampling error, too big to be due to chance. Now these remaining statistics go past the issue of statistical significance and address the issue of how strong is the relationship between the independent and dependent variable. And here we have 3 different estimates: phi, the contingency coefficient, and Kramer's V. They all purport to measure the strength of that relationship, and in theory they all deal with a number that ranges between 0 and 1, with 0 being no relationship, in other words, not significant, and 1 being a perfect relationship. That about does it for Chapter 2. In the next chapter of this tutorial, we will begin looking at an entire family of tabs which involve extensive sorting of results and greatly speed up our efforts. Thank you for viewing.